Good morning. George Hepworth, Grover Park Consulting. Welcome back to the Northwind PowerApps series for Access developers. In this video, we're going to look at a powerful pattern in the SQL Server layer that mirrors one of the core strengths of VBA in Access, modularity. Specifically, we'll cover what I call helper stored procedures and how they make our back-end code cleaner, reusable, and easier to maintain. You may think of these as subroutines. I think you'll recognize the approach right away. Just like in VBA, where we break complex tasks into smaller, well-defined functions or subroutines, we can do the same in SQL Server using stored procedures. This makes each part of the logic easier to read, test, and reuse. Instead of putting everything into one massive, unreadable stored procedure, we encapsulate a single responsibility in each helper step. We make our main procedures cleaner and more focused. We enable reuse across multiple features and business rules. To illustrate, let's take a look at product inventory. When we open a product record, the screen displays real-time inventory and reorder information. We can look at products detail for T. When the screen for a product becomes visible, it displays attributes of that product, which are editable. They're shown here with a white background and a pale blue border. Other values, the quantity to sell, quantity in no stock status, quantity in allocated status, and quantity on order, along with the calculated value of quantity to reorder on the next purchase order, are disabled. They have no border and are not selectable. These values, displayed on the right-hand side of this section, are calculated in a stored procedure called quantity to reorder. Each of the components in this reorder calculation is calculated within that master stored procedure by one of its helpers. These numbers are not calculated in PowerApps. Values displayed come from the output parameters from a single stored procedure called product reorder quantity. Product reorder quantity is a master stored procedure. It gathers the required inventory data by calling multiple helper stored procedures. This includes a sub-stored procedure called product last stock take date and quantity on hand, or QOH, product no stock, product on order, product available, and product allocated. In addition to the helper stored procedures in product reorder quantity, we have our standard error handling, which includes the custom error message stored procedure and the error output parameters for the error code and the message, which are used to generate a user-friendly message if an error does occur. Let's look now at the actual stored procedures. This is the product reorder quantity stored procedure. It takes as an input parameter the product ID of the product we want to collect information about, primarily the product reorder quantity. The output parameters are the product reorder quantity, which is calculated in this stored procedure. It also puts out other output parameters. These are retrieved by various helper stored procedures called here. We also return three output parameters, the unified ID, which is the product ID. If there is an error, we get an error code and a message. Those are passed into our custom error message stored procedure in order to provide a user-friendly error message. Skipping down, to the first of our helper stored procedures, product, last stock take date, and quantity on hand. Again, we ask for the specific product which we're evaluating right now. We get back two values as output parameters. The last or most recent stock take date for this product, and the last or most recent stock take quantity on hand for this product. Our error codes, if we encounter an error, will be passed into our custom error handler. We have the last stock take date which we need for our further calculations. The next helper gives us the quantity of this product in a no stock status on all open orders. Next, we retrieve the quantity of product in on order status. This is an example of encapsulation and singularity of purpose. Product available and product allocated, which is the next stored procedure. I frequently struggle trying to explain this, so bear with me. I decoupled the product allocated subprocedure from the product available subprocedure and call both where they are needed in this procedure. The stored procedure, product allocated, run next in this sequence, is also called inside product available, where it is needed for that calculation as well. I also call product allocated in this level where it is used in a different way. That might make more sense if when we take a look inside each of these stored procedures. Let's move on. As I just mentioned, the next stored procedure in our sequence is product allocated. At this point, we have gathered all of the components of our calculation that we need in order to calculate the minimum reorder quantity for our current product. Before we do that, let's go back and dive into each of our sub-stored procedures in turn. Well, to do this very quickly, I won't dwell on them. I just want to show you how they work. Let's start with product last stock take date, QOH. As you'd expect, we pass in the product ID as the input parameter. We use the stock take table and select the maximum stock take date for that product. This bears a bit of explanation. In order to make sure that my stock take values always come before any purchase order or order on the same date, I cast the stock take date as a date only, so it comes out, for example, 2025-07-16-000000. That way, the stock take date is always earlier than any other date value on the same day, meaning the stock take is available first, and then purchases and orders are charged against that stock on that date. We do the same for the stock take quantity on hand using the product ID and that last stock take date. We return the stock take date, quantity on hand, and the date back up to our parent stored procedure, product no stock. Also very simple. We go to order details. We find the sum of all outstanding orders where the order detail status is 4 or no stock. We pass that back up to our parent stored procedure and move on. Product on order, the same pattern. We get the sum of all quantities on purchase order details for that product, where the product ID is the one we're looking for, and this PO is approved. It's in approved status, which means that it's gone from submitted to approved, but it hasn't yet been shipped. So we know it's going to come, it just hasn't come yet. Product available, more complicated. It involves a couple of steps. I'll just hit a couple of these highlights. First, we want to ensure that if we have a newly added product, it may or may not yet have gone through a stock take. It should always have a stock take because of other steps we take, but just in case, this is defensive programming. If that product doesn't appear on a stock take yet, this stored procedure will put it into a stock take as a starting point. We're going to again find the last stock take date quantity on hand, which we'll need. Next, we'll find out how much product was sold. This is another helper stored procedure at a lower level, so we're now 3 levels deep when we get to this one. It will tell us the quantity of that product sold since the last stock take date. We can send another helper to get us the quantity of product bought since the last stock take date. We again figure out how much of our product is in the allocated status, and we use all of those quantities that we've retrieved from various helper stored procedures in our calculation. Quantity on hand from the most recent stock take plus quantity bought since that last stock take minus any quantity sold since that last stock take minus quantity previously allocated on unshipped orders. And this calculation returns the local product available to sell, which we pass back up through our output parameter so that it's available in our calculation here. The last stored procedure that runs is our custom error message. I won't go into this in detail. Basically, we give it an error code and an object, whatever object raised the error, whether it's an order or an order detail, etc. If it's null, we set the custom error code to -1 and say, I can't figure this out. We do the same with our current object, make sure we have a valid object that we can work with. Then we go to our SQL Server errors table, find the error message that corresponds to our error code, and pass that back out. At this point, we have gathered all of the values we need for our calculation of the reorder quantity. These are the dynamic components, such as the product allocated, the product available to sell, product on order. We're going to put them to work with the static components from the table by retrieving the defaults for minimum reorder quantity, target level, and reorder level from the products table itself. We select minimum reorder, product target level, and reorder level from the products table. With the dynamic contents and the static contents, we're ready to go through the step-by-step process of figuring out what our minimum reorder quantity needs to be at this point in time for this product. The calculation says product already in the warehouse plus product on a truck coming into the warehouse is compared to product on orders with no stock to fill them plus our target level. If our product available and product on order is greater than our product no stock and product target level, then we're just going to use the current minimum reorder quantity. We don't need to order anything. However, if this is false, then we need to reorder. The next question is how much? The calculation here says we take products on order with no stock to fill them, plus our target level. Then we subtract the product available in the warehouse and the product on a truck coming into the warehouse. That gives us the product reorder quantity based on these dynamic levels. But then we compare the dynamic to the static. If the static minimum reorder is greater than this calculated or dynamic reorder quantity, then we're going to use that minimum reorder quantity. Although we currently need less than that, use the minimum reorder quantity anyway. In the absence of an error, we go on out. If an error has occurred, we send it through our custom error handler in the custom error message stored procedure. That's basically the story of how this singular master stored procedure uses multiple sub-stored procedures, what I call helpers procedures, to gather the bits and pieces we need to go into our final calculation to send back the final reorder quantity we need for that product at that point in time. My final thoughts. This video highlighted one major class of stored procedures, helper procedure. We used the multi-levels of logic in product reorder quantity as a case study. We didn't go through all of the helpers in this app. There are many. Once you understand the pattern, you can extrapolate it to any complex calculation or decision. Good architecture isn't just about what the app does today. It's also about how easy it is to maintain and scale in the future. As Access developers, all of this should be familiar to you. It's good to know that you can carry that knowledge over to a new environment when you add PowerApps and SQL Server to your toolkit. If you found this helpful, like, subscribe, and stay tuned. In coming videos, we'll shift again and return to the PowerApps UI.